Good morning or good afternoon. Mr. Lesham is here. Thank you, Bruce. We are still with Trig and we're back in identities. I think identities is kind of like either you like it or you hate it. Personally, I like it because I don't have to deal with numbers, but it's up to you. What we're going to do differently to last year is that we're also going to use the double angle formulas, maybe the compound formulas as well, I guess. Yeah, compound formulas again as well. I won't write them now. If we need them, I'll write them. But to that, we need to add the basic identity tool. So we need to remember that sine squared theta plus cosine squared theta is 1. And that tan theta we can replace with sine over cos. Okay? So using this in the compound formulas, which I'll add later, we need to prove things. So let me just spend another half a minute about this proving thing. We are asked to prove that tan theta plus cosine over tan is sine 2 over sine 2 theta. Okay? Now, what you shouldn't do is look at it as an equation, solve for theta. We're not solving for theta. We actually need to prove that the left-hand side becomes the right-hand side. So in drawing them, we're going to start, we normally start with the left-hand side. We don't have to, but normally we line them up for you where it's easier to start from the left-hand side. And we do a bunch of stuff, we go around, and eventually we get to the right-hand side. Okay? That's what we normally do. In the really tricky one, it's actually very difficult to get to the right-hand side. So we get to a certain point where we stop, and then we go from the right-hand side backward and hopefully meet the same point. We'll see if there's an example of that. Okay? So as I said, we start from here. So I'm gonna write down tan theta plus cosine theta over sine theta. Okay? So the first step is probably just to write down the tan. Okay? The tan is sine theta over cosine theta. Okay? And to that I need to add cosine theta over sine theta. Okay? So that was just simple use of that. What's the next step we can do? When you have two fractions, what do you need to do? Common denominator. So the common denominator is simply cos theta sine theta. Okay? And then that will be sine squared theta plus cosine squared theta. And now we can use that first one. Okay? What is sine squared plus cosine squared is 1, right? Okay. Now I've got sine or cos. It doesn't matter. I can start with sine, right? It doesn't matter. I can swap them around. Now at this point you've got to stop because there's nothing obvious that you can do. And what you should do is look at to where you want to get to. You want to get to that. You want to get 2 over sine 2 theta. So now I've got two options. I can either just stop there and go from the right-hand side backward, which I think I'm going to do with you, or I can try and be clever and carry on. Okay?
You multiply by 2.
Okay, right. So I'm going to do both. Okay? And I'm going to do both because we actually done this. I mean, what is sine theta, cosine theta? What kind of alarm bells go out?
Sine 2.
That should be sine 2 theta, except that I'm missing the 2, right? Yeah. So what should I do if I'm missing the 2? Just put 2 sine theta, cosine theta. I can do that as long as I've got a 2 here as well. And then it cross cancel, right? Okay. And now, what is 2 sine theta, cosine theta? Sine 2 theta, not cos square, sine 2 theta, right? And done. I'm finished. I start from the left-hand side, went all to the right-hand side. Now, let's say you didn't have this amazing epiphany and you realize you need to multiply 2 divided by 2. You could stop here. That's fine. Let's say you stopped here. Okay? Then, if you stop here and you didn't do anything further, then you take the right-hand side. You say 2 over sine 2 theta. Okay? Now, what is sine 2 theta? You use that, right? 2 sine theta cosine theta. Okay? And now we can cross cancel the 2. So I'm going to have 1 sine theta, cosine theta. Okay? And then you can realize, well, these are the same. These are the same. So I prove that the left-hand side is equal to the right-hand side. I'll pause here. Maybe just to add to that, to make sure you pick up the point, what we're trying to do, let's say we didn't write that. We took the left-hand side all the way to here. So actually write down left-hand side is equal, up to here. And then if you picked up the right-hand side, then right-hand side equal to blah, 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 and you end up in the same place. Understand? That's just to make sure that you'll get all the marks. The next one is we need to prove that tan A equals sine 2A plus, divided by 1 plus cosine 2A. Now, I normally tell you start from the left, get to the right. But here I shouldn't really start from the right. Can you see it? When the left is, okay, I can convert that to sine over cos, but then what else do I do? You always want to start with the more complicated side and then trying to simplify it. It's easier to simplify things than to make them complicated, okay? So we're going to start, I'll just give you the habit. Let's start right-hand side equal. And we're going to say sine 2a 1 plus cos 2a. I'm obviously going to use the double angles, okay? So 2 sine a cosine a divided by 1 plus. What is cosine 2a? Okay, now I need to figure out which one I'm going to use. Yeah. Now, why the second one? Why, Jeannie said the second one. Very clever. Did you say that?
Yeah.
Why would you use the second one? Because I have 3 options. What made you think to choose the second one?
Because the ones you cancel, then you can divide it by 2.
That's it. You see how it's important to not memorize but remember it. You see, there's a minus 1 and I've got plus or 1 plus. So if I'm adding this, okay, it's going to minus those 2 and I'll have cosine A. I'm going to start cancelling each other out. So I'm not saying if you picked that you couldn't have done that. You could have, but it probably will be harder. Okay? So I'm going to write that again. 2 sine A cosine A equal 2 cosine square A. Okay? Now, cross cancel the 2. Here I've got cos A and here I've got cos square A. So I'm going to cancel that. And I'm simply going to have sine A over cosine A. So don't skip steps here, I would say. Don't skip steps with identities. Because we need to show that you know that sine A over cosine A is tan A, which is your left-hand side. Okay, so we always go from one side to the other.
So you can just do that and be done.
Yeah. Nothing else you need to do. Okay? Cool. Right. The next one is going to be a classic thing where we're going to have to work from the left-hand side to one place and right-hand side to the same place. So we're going to start from the left-hand side, okay? But we could have started from the right-hand side, doesn't matter. And I'm going to write cosine 2 theta divided by cos theta minus sine theta, okay? Now, okay, which one do you reckon we should do? It is the first one, and hopefully you guys will see it in a second why, okay? Okay, now let me ask you a question. Can I cross cancel like those 2 and the square? Can I say, oh, that's just cosine minus sine? No, because we have minuses. It's not multiply. I can't cross cancelling anything right now. Okay? Because it's a sum or difference. But what I should do, what should I do with the top? What is the top? So it's a difference of a square, isn't it? A square minus another square. So we should write a cosine theta plus sine theta times cosine theta minus sine theta. Can you see it? Okay? See, that's why you actually have to memorize that formula. And I know you hated it in Formula 10. Okay? You have to memorize that one. You really have to. Otherwise you won't be able to see it. And then we cross cancel that. And we got cosine plus sine. But I don't have cosine plus sine. Oh, okay. So what I do is I just highlight it. I mean, that's simple. I can't go more simple than that. And then we pick it up from the right hand, or from the right hand side. So if the right hand side is sine over tan plus tan times cos. And guys, this is really easy. All we do is just write tan in the form. So it's going to be sine over what? What is tan? Sine over cosine. Okay? And this is going to be sine divided by cos. That's the time cos. Okay? Now, the second one is easy. Cosine cancel. I know this one is going to be a bit tricky. What is sine divided by sine over cosine?
1 over cos.
Almost, but you're close.
Cos over 1.
Okay? So what we're going to do is, you flip that one. You flip the sine over cos, you flip it. So it's going to be, I'm going to do it in 2 steps. It's going to be sine, that's the sine, which we multiply by cos over sine. Okay? I just multiply by the inverse of that. And this is plus sine, and obviously this is just cosine. So we get cosine plus sine. I don't know if you guys still see it there. Okay? And then that's it. I just need to highlight it, show that it's the same. So the left hand side got to there, the right hand side got to there. I'll pause and give you a chance to ask questions. And I didn't write down what's that going to be equal. So I need to prove that this is equal to 10. Okay, so let's start with the left hand side. It's a more complicated one. And guys, I've just got double angles. Let me write it down here. So I'm going to convert each of the double angles to a non-double. Cosine 2 alpha. Whenever I have 2 cosine is more difficult because there's 3 options. Now, ultimately guys, you just got to try it. And try, you pick this one, anything happens, give it a minute or 2, it doesn't happen, or try it else. Okay? I think, well not think, I actually peeked in the book, but because I have sine alpha here, I'm going to go with that one. And you'll see what will happen. So I'm going to write 1 minus sine, okay, let's write down the whole thing again. Okay, you know what, just to save time. No, I'm going to be a good boy, okay? Cos 2 alpha plus 2 sine alpha minus 1. 2 cos alpha minus sine 2 alpha. Right, let's start using formulas. So I'm going to use the third formula. Minus sine square, or 2 sine square alpha. Plus 2 sine alpha. Oh, you know what, I guess because of the same reason as what Jeannie said, that the ones cancel, that's quite good. Okay? That's quite good. But there's another thing, another nice surprise there. And here I'm going to convert the sine to alpha, so it's going to be 2 cosine alpha minus 2 sine alpha cosine alpha. Okay? So now I'm going to cancel the 1, so I've got, I'm going to write just the 2 sine alpha first because it's positive. So 2 sine alpha minus 2 sine square alpha. The 1's cancel out. And this I'm just going to write 2 cos alpha minus 2 sine alpha cos alpha. Now that looks like a little bit of a dead end. Dead end. Okay? Because what can I actually do? Okay? And what you gotta do is, one of the things that we need to think about is factorizing. Why factorizing? Because right now I can't cross cancel anything because of those minuses. But I can factorize the top and the bottom. What can I pull out at the top?
2 sine.
2 sine alpha. Okay? And that's why I actually chose that third one, because that third one, this one will give me sine alpha, and then I have another sine alpha here. So I have 2 sine alpha. If I chose the other one, I wouldn't be able to factorize the sine alpha. So that's going to be 1 minus sine alpha, right? Okay. What can I factorize here? 2 cos alpha. And again, I'm going to have 1 minus sine alpha. And you see how neat is that? Okay? So these brackets can cross cancel. And the 2. And I've got sine alpha over cosine alpha, which straight away I can write as tan alpha, which is the right hand side. So we squash that one as well. Yes! Okay. This one is quite a tricky one. You can see on either side you've got some difficult stuff. So I think maybe we'll have to work on both sides and hopefully meet somewhere in the middle. So we're going to start with the left hand side. And I'm going to actually skip, instead of writing the whole thing. Okay, let's convert the cosine theta. Okay, now what do you reckon? Okay, what do you reckon we should use here? Because I've got cosine theta, I would go with the middle one. Because then we can factorize something.
And the sun squared at the bottom?
Ah, you'll see that in a second. With that one, yeah, you see, yeah, you'll see what happens, okay? So I'm gonna write 2 cos squared theta. You should already, guys, in a test, you gotta write this thing first, okay?
Yeah.
Minus 1 plus cosine theta, okay? And here I've got, okay, what should I write instead of sine squared theta? Because I want cosine squared.
1 minus cos.
Good one, Michelle. 1 minus cos squared theta. Okay? I think that's what I'm gonna do. Yeah, yo, that's a tough one, guys. Okay. Okay, now that is a tough one, guys. That is a tough one. Okay, so now nothing is cancelled. I can't factorize anything. What can I do? Well, we can't factorize the bottom. We can definitely factorize the bottom. What is that? It's the difference of the square, guys. It's the difference of the square. 1 minus cos, 1 plus cos. Okay? Now, sure, guys. This is, and I'm just going to write for you. Well, no, I will do it for you. We'll just write it down. So I'm going to rewrite it here because I don't want to do one more step. Okay, no, I will do it. So what I'm going to write is 2 cosine squared theta plus cos theta minus 1. Now I need to factorize it. How am I going to factorize it? What is this? It's a trinomial. Who said that? Sven. Okay? It's a trinomial. So when we try to do trinomial, instead of a cosine theta, what should we do? What do we call that? Cosine theta is equal to? The K method. Sometimes it's worthwhile using the K method, right? Okay? So now I've got 2k squared plus k minus 1. You don't have to use the K method. You can just leave it as cosine theta, but it's going to be harder for you to... and in fact, if you want to use the calculator, which you probably should, then you got to get rid of that cosine theta. And now I have 1 minus k, 1 plus k. Now that we're going to put in our calculator, right? We know how to factorize now. We're not even trying to think about it. We just factorize and use the calculator. That's going to be, and I'll just tell you, okay? So it's going to be 2k minus 1 times k plus 1. Let me see that works. It does work, okay? And then I've got 1 minus k, 1 plus k. Okay, are we happy with that? Okay, what do I do now? Cross cancel. Okay, lastly, well no, not lastly, obviously, but I need to go back to our theta. So I'm going to write 2 cos theta minus 1 divided by 1 minus cos theta. That's a tough one, guys. That's a tough one. Okay? So I got to here. This is as far as I can get with this. Okay? I didn't have to do the K method. In the book they didn't. They just work with cosine. But I know you guys would like to use the calculator, so you should really do a K method. Okay, now if I didn't manage to get to the right hand side, then I need to start with the right hand side and see if I can get back to this. Okay? Right? I'll just do it a bit quick because our time's running out. Okay? So 2 sine theta minus, instead of tan theta, I'm going to write sine over cosine. Okay? Is this going to help me, this thing? Am I doing it the right way? Yeah, looks like it. And then instead of tan, I'm going to get sine over cosine minus sine. And then I'm going to get, what you call it, common denominator for the top and common denominator for the bottom. Nightmare, eh? Cosine theta. And here I'm going to have 2 sine theta cosine theta. So I'll multiply these two. Minus sine theta. Divided, big fraction. Here I'm going to have also cosine theta. And here I'm going to have sine theta minus sine theta cosine theta. Okay? So I did the common denominator for the top, common denominator for the bottom. Okay? Let's work it simultaneously here. By the way, I think, what did I do? I think I did something wrong in the, no, that should be fine. Where do I need to get to? To this. Just to pause a second. Okay, we just hope it's gonna work. Yeah. Okay, so what are, yes, now I see what I'm gonna do now. So first of all, I'll do it in 2 steps. I'm gonna first of all flip that. So I'm gonna have 2 sine theta cosine theta minus sine theta divided by cosine theta, that's the top, multiplied, okay, multiplied by this. Cosine theta divided by sine theta minus sine theta cosine theta. Okay? The first thing to do is cross cancel the cos. Okay? Can you see that? Cross cancelling these. Now, is this the same? Can I cross cancel something? There is a problem here, isn't it? There's a problem that I've got a 2 and I don't have a 2 there. So I can't just cross cancel it. Okay, let me just pause to make sure I didn't make any mistake. So yeah, I can't cross cancel it there, but Finn already said at the top and at the bottom I can take a common factor. The top I can take sine theta, so I'm going to write this here. That's equal to sine theta, taking the sine theta here, and I'm going to have 2 cos theta minus 1. Okay, that's the top. And divided again, I'm going to take sine theta here, sine theta, and here I'm going to get 1 minus cosine theta. Okay? And then I'm cross cancelling these guys. So yeah, I'm not sure how much of this video just stopped, but after cancelling the sine theta, I end up having the same thing I've got here. So I start from the left hand side I got to here, the right hand side I got to there. Help your examiner, circle it, highlight it, just show that you understand from either side you got to the same spot. Okay guys, I'm gonna stop the video here and I'll give you homework. Bye-bye.